Hello and welcome. We appreciate that you could join us today, and I do hope you're having a marvelous day. I'm your host, Charles Collegy, the security analyst for Accelerated Strategies Group. Now, today's DevOps webinar is brought to you by WhiteSource, and I have with me Maciej Mansfield, who is the Senior Product Manager at WhiteSource, and Eylam Milner, co-founder and CTO of Argon Security. And they'll be speaking on dependency confusion. How easy is it to hack into organizations, and what are the available solutions? That's a mouthful. I know you two are eager to discuss the various types of supply chain attacks and your experiences in defending against such attacks. However, the meat of today's webinar must be delayed a few moments, as I have to handle the housekeeping items. Now, please note that this webinar is being recorded, and later it will be available on demand. You will receive an email with the link, but at any time you can go to devops.com and gain access to this and all of the archived on-demand webinars we have available. So feel free to peruse our webinar library. Now, a few moments on the Big Marker platform. First, on the right-hand side of the screen, you will see the chat button. This feature allows everyone online to interact during today's event. Say hello. Let us know where you're located. Feel free to provide comments and immediate feedback. We do want to hear from you. Now, questions we ask that you do not use the chat. Sometimes they can be missed. And if we have a good chat going on, they're going to get moved up and we're going to miss them. So please, if you have questions, place them within the Q&A window, which is accessed directly to the right of the chat tab. So there's a Q&A tab that is right next to the chat tab. And we're going to try to answer as many of your submitted questions as possible before the end of today's session. Now, if we're unable to get to them, I'm sure WhiteSource and Argon Security will follow up. Now, lastly, so that's where we're going for that. Now, the most important housekeeping item is at the end of today's webinar, we will be awarding 4 $25 Amazon gift cards. So please stay with us till the end to see if you're selected. Now that's it with the housekeeping deal. Now it's time to jump in today's session with Maciej and Eylam. So if you could please introduce yourselves while we're talking, but now it's time to jump into the session. So Eylam, I believe you will be kicking off the presentation, so take it away.
Thank you. Hi, everybody. Thanks for coming. My name is Eylam. I'm the CTO and co-founder of Argon. I lead the R&D and product development of the company, which is a great job because as part of doing that, I get to speak on a daily basis with a lot of amazing DevOps teams and hear directly from their source about the day-to-day. Hopefully, I can forward some of the insights here with you today. My background as an engineer started in IDF's Mamram, and then I served at the OFIC unit of the Air Force. A word about Argon. So Argon's mission is to help companies secure their software delivery pipeline. We do it in a variety of ways, and we'll touch on that further as we go.
Hi, everyone. My name is Maciej Mansfield. I'm a senior product manager at WhiteSource. The way I got here is quite interesting. Software startup that I built got acquired by WhiteSource a couple of months ago. It's called Defend, and it is focused on open source supply chain security, which is part of the supply chain security. We're going to talk about it today. Similar to Eylam, I have an engineering background. I've been in the engineering department, whatever it is, for half of my life. And I work from Krakow, Poland. As I said, I work for WhiteSource. We automate open source security and compliance workflows. We offer one-stop shop for all of the open source, regardless of languages or environments. And we try to do our best to help you focus on what really matters by warranting no false positives and trying to help you prioritize vulnerabilities that based on their impact to your software. We're here today to talk about the dependency confusion attack, but I know that there are many people here listening that have no idea what it is. And in order to get to the dependency confusion, we're going to paint the picture of what is supply chain in software development, what are package registries, what are package managers, artifact managers. We're going to briefly talk about risks involved with using open source software and any type of software that isn't of your control, whether it is open source or proprietary. And we're going to do our best to give you some general guidance on how to countermeasure the problems that you might be facing when using open source software in the context of the dependency confusion attack. Kicking off and passing the virtual microphone to Eylam. Eylam, what is supply chain?
Okay, great. So jumping right to it. First, supply chain as a term. It describes something from the real world, the physical world. So a supply chain would be anything needed to deliver your product, including all the components that take part in it or affect it in any way. So for example, delivering food, specifically, let's say delivering ice cream, which is a great thing to have delivered to your doorstep. So when I order ice cream to my house, there are all these different steps that are taken from the time of ordering and up until the time it is placed next to my door. So there's a list of ingredients that goes into the making of it. There's the special packaging to keep it, the pickup, the delivery, and finally the drop-off. But not only that, but a lot of external conditions also affect this product. So just one example would be possibly keeping it at the right temperature, because any variation of that would result in a bad ice cream. So taking the analogy to software supply chain, essentially, we can see it here. Essentially, this is anything that goes into your code or affects it from the moment one of the engineers has written a new line of code throughout the build process, building it, the packaging as an artifact, and finally deployment. So this includes, we can see some of the major components here, the code itself, obviously, the repositories that store it, the team of engineers contributing to it, all the dependencies being used, taking it a bit to the right. So the CI pipelines building your application, the list of instructions that they apply on it, any external dependency that they have themselves, and of course, finally, the handling of the output, usually some binary artifact, which is the final result of the software delivery process.
You've mentioned CI. Would you mind also explaining what is the difference between CI and CD? Because we have a variety of people listening, and I know that some of them may not know the difference.
Okay, sure. So CI/CD are two terms. Usually they go together. One means continuous integration, the other continuous deployment. So the CI part of things is a set of instructions that you perform on your source code and achieve a final artifact as output. So the results of this phase is some sort of package, a software package, where you can take and deploy to the relevant environment. So this is where the CD part takes into effect. The CI results in a package, the CD basically means taking this package and placing it in your development, staging, or production environment. Placing them together essentially means taking files of code, just text files, and achieving some running instant of them as an application in the relevant environment.
Awesome. You gave a really good example on the ice cream, and I want to get back to this. Do you think it is as complex to run software development project as to run a physical factory?
So yeah, I think we can say it's as complex of a process. I mean, I'm not a big expert on physical supply chain. However, I do understand the level of impact a single engineer can have on the entire software supply chain. For example, if any of the developers working on some of the product is able to type a single command and introduce a new dependency to the application, he or she has now affected the entire software supply chain of this product. So I'm guessing it's a little easier to do than affecting on such a large scale the supply chain.
Yeah, I actually agree with that. The power a single developer has is quite big in a company, right? You've talked about the delivery. The delivery pipeline, how complex it is, but it wasn't like that, right?
Yeah, so the software delivery process that we're speaking of now didn't always use to look the way it looks today. So if we take a few years back, it was a much more manual, much more controlled and a time process. So looking back as an engineer, me and the team used to have these quarterly releases of a new version of our product. We'd have Thursday night installation. There would be a specific individual managing such deployment. It's no longer the case a lot of the time. The process is much more distributed. You use laptops, SaaS services, and cloud environments, and it's almost fully automated. So it's enough to push a new line of code to trigger the entire process, eventually meeting your end users with the new version of the product.
Yeah, one thing that came to my mind is that now there are so many areas where the responsibility of a single person or a team is kind of blurred because they separate teams meet somewhere in the middle, right? Let's take a CI/CD. Let's take a CI. Developers can say, well, it is not our responsibility because we ship code. DevOps can say, well, it's not our responsibility if it's not working because you've shipped the wrong code. And security people can say, well, it didn't yet reach staging or production, so it is not our responsibility. What do you think about that?
Yeah, no, I completely agree. I think a lot of the time, these types of situations are the result of a drastic change in technology. So if we take DevOps technology as a whole umbrella term, it saw a lot of advancement in tech-wise, which sometimes results in an organization having to accommodate those changes. So the lack of ownership between DevOps and security team is something that we can definitely see, and things could definitely fall kind of in between them.
It is kind of the same with the open source, right? That there isn't a clear person or team responsible for open sourceness in a company. It became just part of the development cycle, part of the development process, but no one kind of claims responsibility for managing that. And if you think about it, at the moment, 60 to 80% of an average app is comprised of open source. We're building frameworks on top of frameworks, on top of interpreters, compilers, and so on. There's so many layers, and all of it is basically, none of it is basically owned by someone. people just add open source and they say, oh, it's popular. But truth be told, with open source as a part of supply chain, and with supply chain as a concept, there are many risks involved that it's really good to be aware of. You might have an outage. I would say not a big problem unless you're running mission critical. And I'm saying that because you will notice that. People that are here listening to that probably have tools that would ping them if their systems would be down. So I'm not considering it that as a really big problem. Another thing that I've seen is cryptojacking. Building software that would steal cryptocurrencies or mine cryptocurrencies on developers' computers, or that they would steal AWS credentials to farm access, to basically steal credentials to build farms for cryptocurrencies. We can look from two perspectives now, from a developer perspective and a company perspective. Outages, yes, important, but you will notice them. Cryptojacking, yes, from developer perspective, really important. But what I think is the most important thing from a company perspective, when you think about supply chain risks, is actually data leakage or data loss. That's, in my opinion, one of the biggest problems with risks involved with supply chain, or some legal problems. I've pulled some stats from Gartner report, and it seems I'm not the only one afraid of using open source as part of the supply chain. One of the biggest concerns on the security side is usage of untrusted third-party components and lack of accountability. With proprietary code, that also, please keep in mind, is part of the supply chain, you at least have a physical entity behind. We had this discussion with Eylam earlier, that at least you're connected through a credit card with those entities, right? With open source, you may have a GitHub handler and that's all, right? And if you think about it, that's a really big problem, because the stuff you rely on in the supply chain, in open source part of it, may rely on other things. And a great example of this relationship is with NPM, where an average depth of the dependencies is more than 4. So you have 4 layers of dependencies on average. But as I said, it's not only about open source. Right, Eylam?
Yeah, so definitely open source by itself is a whole world. However, it's only a part of the software supply chain. And the thing about software supply chain is that even though we often think of it as one kind of long process, it's actually composed of many different phases or layers. And in order to fully secure it, we must secure each and every layer. Because if we fail to secure even one of the links in this chain, then the chain itself is compromised. So failing to secure the materials, which are just the application's dependencies, could result in an incident like CodeCode. The Sunburst malware, which was attacking at the build time in the build environment, or the dependency confusion, which we'll touch on in a second, which results in wrong artifacts being pulled. So definitely each one of those phases is critical to complete security of the process as a whole. So that's actually a cool survey that Argon conducted. What we did is we spoke with over 200 CISOs and security admins of companies all over the world. And we questioned them a lot about DevOps, CI/CD, and software supply chain. The results of the survey are extremely interesting. I won't go over them all now. However, I'll touch on some of the highlights that I think are interesting to know. So the number one would be that over 90% of the surveyed companies use CI/CD technology to deploy software to production. I guess today this is not really a big deal or a surprise. However, only 20% of those same companies feel they have security and confidence in the process itself, meaning that most security admins feel they don't really know what goes on there, or they don't understand the complexity of it, let alone control it or protect it in any way. Also, over half of the companies use more than 3 different CI/CD platforms, which obviously increase the complexity of it. And possibly the most interesting thing that I find to be from the survey is actually that when we question those security personnel, what is your number one challenge in securing the software delivery pipeline today? The overall number one result that we got was communication between DevOps and security team. And this is great. This is the highlight of the survey for me, because it doesn't evolve around tools, technology, or even code, but it's about people, it's about processes. And I think it correlates well to the point that you made earlier, Maciej, about how the shared responsibility could be between those two teams in the organization.
Yeah, it's actually really interesting how many supply chain challenges and problems are actually related to people, not to the automation algorithms behind that. We're not going to talk about it today because the topic for today is dependency confusion, which is a bit more technical than many other challenges. We kind of briefly painted the picture here. We've introduced all of the things that you need to know to now dive a bit deeper into the dependency confusion, and I will try to make a quick introduction. So dependency confusion or supply chain substitution attack happens when a software installer is tricked into pulling, not always malicious, but unwanted or untrusted code from somewhere else than you would want it to be pulled. Most of the time, that's going to be a public registry or a public source instead of a private one, but it doesn't mean it's always like this. In general, a piece of software has a flaw that causes it to download something from a different place than you would expect it to. And the way it works, it can work from both sides, the package registries and clients, registry clients. And I'm going to quickly explain how that works from the registry client perspective. Majority of you probably use some sort of a registry client, a log file where you define your dependencies, and you kind of go with this. But what you need to keep in mind is that your dependencies, as I said earlier, probably have their own dependencies. They for sure have them if you use NPM. And if you have a lot of dependencies, their dependencies may actually depend on the same packages with different versions. So the role of a package registry client or package manager is to build up an understanding and an agreement in between packages on what version should we use to satisfy all of the requirements. And that is not a trivial task to do. I tried to first understand and then fix bundler for Ruby gems. Not an easy task. A lot of corner cases, especially if you want to keep backwards compatibility, tackle all of the edge cases. It is not easy. And if you start adding on top of it multiple sources, the complexity of resolution grows significantly. And it may turn out that your registry client, package manager, gets confused. That's where the name comes from. It may, especially if you have open dependencies saying, hey, I'm going to work with whatever is the most recent. If you have something like this within your open dependencies, or your dependencies have dependencies that have open dependencies, it may end up confusing the resolving algorithm for a given package manager, which may in the end end up causing it to pull publicly available malicious or unwanted code. And this is how it works from the registry client perspective. The second part of it that can also be confused are private registries, and Elon is going to tell you how the same concept actually happens on the registry side, because I feel that there's been a lot of hype about bugs in resolvers within the package managers, but not many people say, hey, we have the same problem with the registries themselves, right, Elon?
Yeah, that's right. So the package managers themselves help us engineers kind of in the command line install the dependencies we need. The package registries are the software that hosts the packages themselves, but also has kind of dependency resolving logic in them. So a lot of the companies that we work with actually use what is called private package registries. Now, these are just kind of like taking the public NPM, building a smaller private version of it on my organization premise. And so as the development team is installing dependencies, it's actually speaking with the private package registry. However, there's a complexity to it because you can also store private packages. Let's say me as Argon is using MongoDB. So I have a small util package which wraps my communication with it. Let's call it Argon Mongo. Now, this is a package I obviously want to keep private. So I have no interest in publish it in the global NPM. I want to keep it in my private registry in my organization. So I have the ability to store it in what is known as local repository. So these are kind of folders to store artifacts which are private. However, you can also use remote repositories. So this is a way for private registries to access public location, for example, the global NPM. And then you wrap them around with a virtual repository. So you as an engineer only speak with this virtual box wrapping both of them. So this introduces resolving logic. So when I type npm install Argon Mongo, it's up to the package registry to figure out which package I want to be pulled, the private one developed in my organization or one from the outside. And here we see a picture of one being very confused by it. So accidentally pulling a public package named Argon Mongo because of its higher version, as opposed to pulling the package I meant, which is privately developed by my team and is hosted privately in my organization.
Yeah, and side note from me that Alex did exploit this ecosystem really well for a couple of registries, and he elevated several bugs on both the private package registries and registries clients / package managers side. And RubyGems got a bit of a bad press, and I'm part of the RubyGems security team, so I want to clarify, we did detect Alex's work. We agreed it to stay on RubyGems. What that means that, yes, he found technical bugs on both bundler and private registry side, but a lot of bad press was given to RubyGems saying, oh, no one noticed, no one secured that. Not true. The moment Alex published his packages, I did tweet him saying, we know what you're doing. We assessed the risk from those packages, we checked what they do, and we agreed that they can stay. We did the same this year, the same things for at least 70 or 80 packages or versions that were removed from RubyGems registry because they contained malicious code. But let's say you're not that close with package registries, with registry security teams, and you just want to have a way to protect yourself, right? You want to try implementing some solutions, coming up with ways in which you can basically feel safer. I wouldn't say safe, because you never know. There's going to be a next big thing at some point, and obviously especially we need to be proactive and look into other ways of protecting our customers and the open source ecosystem. But I feel that there are a couple countermeasures, general advice that we can give away to people that listen us on how to minimize the risk of an issue like dependency confusion. I'm not talking about tackling all of the supply chain problems, but just doing something to take at least the dependency confusion out of the picture. And we're gonna give you some general advice here. First of all, if you do not use any software, you're safe. If you don't use any dependencies, if you write all of the software by yourself, you don't have a reason to worry, right? And I think that Yoshitaka Sakurada went with this approach. He is an ex-minister of cybersecurity of Japan that confessed that he doesn't know how to use a computer. He never did. And well, that's kind of smart, right? If you don't know how to use a computer, and if you do not use it, you are not going to be hacked. If you don't use an email, your emails are not going to leak. But I think it's just a joke, right? One thing that I can advise to you, and people tend to forget about it, is how important it is to keep your package managers up to date. If there are resolution bugs in package managers, quite often they're fixed. The problem with some of the languages is that the managers are being part of the bundle together with the language. So if you install, let's say, binaries of Ruby, you may end up getting outdated version of bundler. And if you don't update it, if you go with it, it may turn out you're using a version that is potentially unsafe, that might have many bugs, including resolution bugs in it. Always keep your package managers up to date. Obviously, test them, right? Install them locally, see what will happen. But try to keep up with the release cycles of the package managers.
Yeah, so that's another great kind of tip on prevention, because who wants to install an update for the package management? So the way that the attack actually took place was some external entity to the organization was able to create a namespace in, say, the global NPM with the name representing the private company. So if that private company would reserve the name first in the public space of the global NPM, say I take ownership of the Argon as a namespace, then this should be preventing of incidents like this one, because you can only have one. And if I'm the owner, then I control the packages uploaded to the namespace. However, Maciej did point out to me that there is a potential issue with this as a prevention method, because if me as Argon is taking over the namespace in the public NPM, then everybody else can see the naming convention I'm actually using, which is actually a big part of the dependency confusion, because you have to know the naming conventions of the packages.
Yeah, exactly. And the problem with it is you can quite often guess them and you can farm them. What that means is if you have a naming convention that is decent, and you should have one, let's say WhiteSource dash functional package name, right? WhiteSource dash Redis, whatever. An attacker that is aware of it can try to farm other packages along that WhiteSource-PostgreSQL, WhiteSource-MySQL, and so on. It is fairly easy to automate that based on the most popular open source libraries and so on. And what I noticed on the internet, I'm not going to give names of the companies. It's irrelevant. Big company. Its CTO, couple weeks ago, or maybe before the dependency confusion hype happened, published their package log file for Ruby saying, oh, we use that many packages, not that many, with listed both public and private names, right? And for me as an attacker, it's a great hint. Now I know two things. I know their naming convention. I know the exact names of packages they use, so I can check if they're being taken in the public registries. If not, I can take them. But also, I know all of their packages, open source software that they rely on, which means that if I would be really interested in attacking them, I could use other methods and try to attack their supply chain from a different angle, right? And don't get me wrong, I'm not saying, oh, security through obscurity is the best. No, but it's just one of the things. So on one side, it's good to block the names because it minimizes the risk on dependency confusion. But on the other hand, it gives away a bit of a hint, actually, to, hey, we are aware of dependency confusion and we are working towards not having this type of problems. And this is our naming convention, right? And one more advice that I can give to you is to keep in mind that the software development lifecycle starts with you both writing a code, using proprietary software, and using open source software. So anytime you actually pick up a package, a Ruby gem, NPM package, or any other some open source software, please reflect on who is behind it. Do I really need it? What is the functionality? And so on. So, and keep in mind that quite often, just including the package in the dependencies and running the install process is enough to cause really big problems. Obviously, that kind of, I can now move to my second slide, which says, hey, it is a big problem. I am working on minimizing that risk. We at WhiteSource use WhiteSource Defend to detect packages that are malicious or malicious versions, if we're not talking about packages crafted just to be malicious. We're working on detecting them and removing them together with Ruby Gem security team, and we're working on bringing the technology to other languages. And we detected, at the moment, this year, more than 80 packages or versions that were removed from Ruby Gems because they were crafted to either be dependency confusion attacks, malicious packages that aimed to be just to gain control of computers and a couple other things. So always reflect on what type of software you're using, not only open source. And
yeah, and so on Argon side, it's pretty cool because we get to be integrated into the software supply chain as a whole. So we know how to talk with the source code managers themselves and the CI pipelines building them, as well as the private package registries managing the output. Since we get this path, we are able to actually look at all the dependencies used by your application, trace each one's root of potentially being pulled. And if we detect any package that should be private, but is actually on a route enabling it to be pulled from an external source, then we notify and we help even automatically prevent this type of situation. hopefully keeping you far away from the next supply chain incidents like the package dependency confusion one.
Yeah, so it's a broad topic, right? There is so many in the whole supply chain. There is so many things happening. We had a 40-minute long, including introduction discussion on the supply chain, on the dependency confusion, but it's only one of the things that can go wrong. I don't know how you feel about it, Ian, but I recently had this discussion and internal thought that what is a supply chain problem for me may not be for someone else. I may be a vendor to someone else, right? So for them, I am a supply chain. But if my software can be exploited, but not in a supply chain, is it a supply chain problem for my customers? I would say yes. Right?
I think
it may be and maybe not, right?
Yeah, it depends on your perspective, right? On your point of view. Essentially, supply chain attack could mean that someone along the path of the software I'm using has compromised it in any way. So if I'm the end user of this product, if I'm the one that ordered this ice cream home, then definitely, yes, I suffered a very bad supply chain attack. The other side of it, yeah, not so much.
Do you think about starting Argon for physical supply chain security?
I might. I think it's a little bit too hard.
Yeah, it might be, you're right. Okay, maybe people that are listening to us have some questions.
As soon as I get back here, there we go. So we do have some questions, and I always enjoy listening to the webinars, and thank you, Maciej and Eylam, for the information. Nuggets of information I got is that dependency confusion and how those malicious packages can be pulled into. It's an issue, right? With the public repositories, and the more layers, the greater chance of dependency attacks possible. So, but you had some nice advice on how to deal with dependencies. But let's get into the questions from the audience. So the first thing is, you kind of mentioned that private naming convention is very important on how you keep the spoofing of those names or guessing the convention, as you mentioned. Is there anything else that how do you kind of keep that naming space unique?
Okay, I can answer that, Eylam, if you don't mind.
Yeah, sure.
So I wouldn't use the company name. Basically, long story short, I would come up with an internal naming convention within the company with some. I wouldn't go with a random SHA number, but with some internal naming that you stick with. And I would use this, and I would try to educate people within the company that they shouldn't expose it. Obviously, if a bad actor, if someone quits the company and in a year gets back, they still know the naming convention, right? So if they want to do some harm, technically speaking, they could. But as long as the naming convention stays public, it gives you a bit more security. The second thing alongside this, if you use private registries, maybe you should block the network traffic at all if there are bugs in the package manager client's resolution that end up pulling stuff from the internet. It won't fix the dependency confusion issue in the registries, but if for any reason the package manager would fall back to the default registry, if it has one, at least it's going to be stopped on the network layer, right? So we kind of gave two advices that contradict each other: block the names, and at the same time, do not expose the naming convention. I guess you need to weigh with which one you want to go, and pick one that is more suitable for you. I would say be really strict about naming and block the names. Yes, it's gonna be spoofed, But if you educate people and make sure that whenever you decide to introduce a new internal dependency, you double or triple check the public registries to book the name, you should be fine in the context of dependency confusion.
All right, great. So another question from Maggie, and you mentioned the 5 software supply chain layers, and any one of them can be exploited. Is there one layer that is more vulnerable or conversely easier to secure?
Okay, so great question. So just a reminder, the 5 layers of the software supply chain would be the source code itself, the materials or dependencies it uses, the build pipelines building it, the artifacts which are the result of the process, and the deployment, which is taking them and placing them in the right environment. So I can't say with full confidence that any layer is easier to secure in one way or another. However, I would divide them into a couple of groups. So one would be where we are dealing with source code. So the first 2 layers, source code and dependencies, I think are naturally a little harder to make sense because we are dealing with source code itself, raw lines of code. The third layer in the middle is where we build it. So the CI pipelines themselves. This is essentially an area that has seen a dramatic evolution in solutions. So looking at technology like GitHub Actions, which is today the 3rd most popular CI tool used, even though it's only in the market for around 2 years. So these solutions are definitely hard to keep track of, to control over, and to protect, since they are pretty new, and today there is no out-of-the-box way of really doing it. Maybe the final group where we deal with artifacts and where to place them is maybe a little bit easier to secure, since we're dealing with the output, the binaries, which are a little more packaged. And that's kind of my 2 cents on that.
All right, great. And we kind of got a follow-up question similar to that. I'll tell you your answer there, Eylam, and that is, so Anshul wants to know is, can the packages be secured right at the start so that only secure packages get an entry?
Well, if we could do it that easily, we wouldn't be here, because that's the base behind the dependency confusion, right? But to answer this question more deeply, technically speaking, you could rely only on packages that are signed by people we trust, right? But what that means is people have to sign their packages. And it's not that common for many ecosystems. To give you an example, Ruby, there is a way to sign packages. Each time I make a release of some of my open source, I sign it. What that means, if there's an ATO attack where someone would take over my RubyGems account, they wouldn't be able to sign it. So if you use my open source and you configure registry manager correctly and say only trust signed code from this guy, it could be blocked. But there are way more packages and people that do not sign anything that they release, because sometimes it's just cumbersome. So I would say that there may not be a way to secure everything out of the box, or you will end up limiting yourself in an open source space quite drastically. There may be a way to analyze packages, and this is what I am working on a daily basis, to come up with technical solutions to analyze open source that is being released, to assess the risks that come with it, and if something is malicious, to make sure that no one can install it, right? But I don't think we will come up with a way that will get 100% adoption from anyone, because what I also notice is there are groups of people doing open source that rely on automation. Eylam, you say GitHub Actions, right? People rely on GitHub Actions to do releases of software, right? So if you get into the supply chain there, you introduce your malicious code and you make a release. If the GitHub Actions are signing the release will be signed, still containing malicious code. So I would say there won't be a single solution that will get, I'm not saying that someone will not come up with a solution that will get a wide adoption, but I don't believe the adoption is going to hit 100% rate for all of the packages, open source, that you're using. And I would say the same with proprietary code, but Eylam, maybe you have your own thoughts on that one.
Yeah, no, I think we touched on the case of private packages, which are my company's proprietary code, which definitely fall under the categories of processes being vulnerable to dependency confusion. Just by the fact that most private package registries don't limit the scope of packages to only private registries. You can definitely use them as sort of a gateway to access the publicly accessible registries as well. And so definitely working with private registries is not a full solution to be protected of those dependency confusion.
Okay. So Owen wants to know, are there any other examples for exploiting the dependency confusion other than the work that you talked about that Alex did?
Yes. What month do we have? This month. A couple of weeks ago, several packages were removed from Ruby gems that were detected by WhiteSource Defend that were targeting a particular company. Obviously, I cannot give a name, but they were crafted exactly for that reason, exploiting the naming conventions of this company. And I'm not talking about copycats. Copycats are, a whole bunch of them. So for people that are new to the security realm, whenever there is someone that comes up with something new, copycats come along and they try to mimic the same solution, exploiting different companies. So let's say Alex got into Microsoft. There's going to be someone trying to get into IBM using the same idea, right? So I'm not talking about them. I'm talking about packages that were designed to, exploit dependency confusion, but they didn't have a research in mind. So the characteristic of the code that was inside wasn't of a research nature, but was of a remote code execution nature, which means that whatever you want, you can run if you get into that supply chain, right? Alex did a really good job describing what he is doing, not obfuscating the code, not aggregating private data. We can agree, we can have this discussion whether IP is private or not, but he didn't collect any stuff that he could use to exploit the company in any way, right? And for me, that is still a research. While the packages that we detected that were removed had remote code execution code as a first-class citizen to get into whether it's development, CI, or production, and do something. So yes, there are examples. No, they are not disclosed, and they probably won't be.
Okay, so we have one more time for one more question, and I know you kind of mentioned Maciej about people being involved. So Nicholas' kind of question is a little about that. So is the battle to create awareness of the issues within the key stakeholders one that can be won quickly enough to mitigate the extent of which open source is becoming embedded in solutions? So it's kind of, I think he's kind of talking about a race here between being able to get awareness before we start really doing a lot more open source, which you said we are doing a lot of open source now.
Yeah, I don't really know. I feel that there are companies that put security really high, and you can see this on the based on the Gartner report, right? On the statistics that I showed. One of the most important things for 28% of people from the Gartner survey say that open source problems are of their biggest concern. But at the same time, I feel that the industry is moving so fast that there always will be people that won't be able to catch up. Obviously, I could say, yes, please use WhiteSource software offering because it's going to simplify things. But I feel that we might not be able to even reach them. So my answer would be yes, and partially. It depends, right? Software development, it depends. I think that what we're doing here with Eylam is one of the steps. If you have this problem, please send this presentation to your executives. Maybe they will gain a bit of awareness, because I don't believe that it's not that it's ignorance. I think that it's more of lack of knowledge or lack of information, right? It's not that, oh, I don't care about security, whatever happens with my customers' data. Yeah, irrelevant. I don't think that's the problem. I think that the awareness and being aware of consequences of not putting security, maybe not always as in first place, but at least second or third, that is something that can convince many of the executives, right? Especially if you come with examples. Hey, we use this software, it got hacked. If it would be us, think what would happen. There are some solutions that we could use, or there are things we can do better if we have just a bit of time. So my answer is it depends. But let's ask Eylam.
Yeah, so that's a very broad question. I wouldn't want to speculate. So just from my personal experience, I am a little optimistic about the awareness of these types of attack, because just not so long ago, maybe a year and a half, the term software supply chain wouldn't mean what it is today. And I should know, because I speak about it roughly 24/7. And the awareness that exists today, as opposed to just last year, is pretty remarkable. So anything starting from CISOs, security teams, application security engineers, to DevOps and any participants of this webinar, definitely picking up the right track to acknowledge this as a critical component of the software we use and the software we produce. So I'm optimistic overall.
Right.
Actually, one more thing. When you talk about it, 1 minute, we might be forced as an industry to acknowledge that, and then there won't be a discussion, right? Biden's executive order includes a section on the software supply chain security. So even if we're unable to spread awareness, I think that in a couple of years, the awareness is going to be forced on us by law, and then there's not going to be exit, right? It's going to be like GDPR, enforced. You need to obey. You need to use certain ways of protecting your software and so on. And if we go that way, awesome. For me, awesome.
Yeah, I think there is going to be some movement in that way. But I have to say, in the short term, these sort of webinars are what is designed to raise that awareness. And as you mentioned, Maciej, if you have somebody that is going to be in this space or has questions, send them the link. Make them go to devops.com and listen to this and get some ideas. But I have to say now we are out of our time. It is going to be, I have to finish up with awarding the $25 Amazon gift cards. So the 4 attendees who were selected are Bianca P., Sherry W., Jim D., and Stefan S. So you will receive an email to the email address that you registered for this webinar. And if you're like me, you have like 7 different email addresses, so you got to kind of figure out which one you registered under. But the email will explain how you can retrieve the gift And don't forget to check your spam filter to if you don't receive it soon. Now, I want to again thank Maciej Mansfield and Eylam Milner, our sponsor WhiteSource and partner Argon Security, and you, our audience, for taking an hour out of your day to spend it with us. Goodbye, and may the fickle finger of fate be kind to you.
Have a great day and please stay safe.